Hey, and welcome to P&W Repair. If you're joining us for the first time, I'm Andy. Today we are reassembling a 17.5 horse Briggs and Stratton. Stick around. So I think this is my fourth pass with the hone. Just trying to clean these vertical scratches best I can. And we're also taking off that glazing from the cylinder wall. I don't know how much more is really going to come out. I can still see some of the vertical scratching. I can't catch them with my nail. They shouldn't cause a problem, I wouldn't think, but I'm tempted to keep going after it. But I mean, you also don't want to be removing tons of material. Don't want our bore size to be messed up. Nice dull finish throughout the cylinder, so not all glazed over. I think we're going to get back to cleaning, and we're ready to go back together at this point. Now, being that the original issue with this engine was compression related, I am going to thoroughly inspect this piston along with my new rings before I reassemble. I'm not big on doing the same job multiple times, so I'd rather just, take the time and do it correctly the first time. So at this point, we've honed the cylinder. I'm happy with that. We are going to start with our new set of rings by checking our ring end gap. Our spec for our compression rings is 30 thou. The gap's bigger than that, then they're a reject. So we're going to we have some of the more expensive rings, from what I understand, you can buy for a Briggs. They're a Lil Red Barn brand, which they should be decent quality from what I understand. So we'll verify that by checking our gaps. To do that, you simply put the ring in the cylinder, push it down about an inch into the bore, and then take your feeler gauge at the gap. If I can fit a 30 thou feeler in there, then it would be a throwaway. Being that I can't, that compression ring's good. Now we'll just verify that with the other one. Beautiful. Yeah, those are nice and tight. Okay, so our compression rings are good. Now for our oil control rings, their spec is 35 thou. So damn flimsy and little. Not the easiest thing to hold on to. So we'll get our 35 thou feeler. Plenty tight. Yeah, I mean, could just take a guy's word for it. They were new in the box, but I'll tell you right now, that whole acronym new stands true more times than not these days. Never ever worked. But in our case, our ring gaps look good. So from this point, I'll go ahead, pull our old rings off the piston, clean our lands, install the new rings, and then we'll measure our ring land wear and just verify that that's within spec. So we will go ahead and install those. Start by pulling our two compression rings. Oil control ring, you typically don't need piston ring pliers for. They should come right out. Beautiful. Let's grab a pick. Really, there's no, I'm going to just hose that out. There's no carbon buildup. I'm going to brake clean that out. Get back with you after I do that. So we've got our rings installed on our piston. Our next measurement we're going to take is our ring land. Check them for wear with our new rings installed. The spec on that, since this is a 3100 series, or 31,000 series, no, 310,000 series, sorry, engine, according to our manual, our spec should be 9 thousandths. So if I could fit a 9 thousandths feeler between the ring and the land, then our piston's junk. Which I don't have a 9 thousandths in this feeler gauge set, but I do have an 8. So if I can fit an 8, then we'll worry about it. But if it's tighter than an 8, then there's nothing to worry about, which I can tell that compression ring 100% nowhere near 8 thou. We'll check this other one. It's not a bad idea to check them in a few spots either. Yeah, we're good on that front as well. So at this point, we can put our ring compressor on and install the piston. Well, our manual is not the actual manual for a 3100 series, though it is very similar to a 3100 series. A lot of the models share a lot of the same parts. So this is the manual I got. It does not list a torque spec for a 3100 series bearing cap for the connecting rod. It does, however, list it for 2300 or 23,000, 24,000, 3,000, and 32,000. 100,000, I should say. Spec as 190 inch-pounds. This is a 310,000 series. We're going to run it at that 190 inch-pounds. I think we'll be all right. So we're going to go ahead and torque the bearing cap. Okay. Rod cap torque. On to the next. So this is kind of a bit of trial and error here. For some reason I wasn't real clear on how I disassembled this governor assembly, and being that I have the incorrect manual, that's not a whole lot of help. So we are going to see what we can figure out. I do know, spin my camera around, we're going to line up timing gears. And I do know from my disassembly the keyway I had indexed right along that casting up to the edge behind the starter there. So that there, where they held my there it is. Kind of need the keyway, don't I? But, dummy, like I said, trial and error. Get something to tap that in there a little bit better, huh? A little even. All right, try that on. That's better. So on that note, timing marks are now lined up. I'm going to go ahead and take all of these bolts out right quick. So now, the only thing I really question is that must be retained. Okay, I see how it is. It's in the lower section of the case that holds that up, or holds that in position rather. So I need to figure out how, as far as this governor shaft goes, we're going to have to get a better understanding of where to set that. I mean, just in theory, I would say it should be all the way down. That way when your engine RPM comes up and the governor weight expands, it pushes up against that, which will turn that lever, which will increase throttle. Right? Let me do some research. So I believe I've figured out this governor assembly. Basically what I did, without the governor weight cage, that's what I'm going to call it. I don't care what you call it. Without that on the camshaft, so actually if I just take that off, I ran the governor shaft as far this way as it would go, and then I set that back on there, and it would only go so far in because of the governor assembly here. So I ran it up against the face of that, and then slid my linkage on down here and did just the opposite. Ran that to where we were at our stop against the bottom of the linkage here, and tighten that nut down. Now, oops, you can see when that's in there, it'll be all happy and do its thing. So what'll happen is it spins up, those weights will come out, and it'll push on that lever. Simple enough. So from this point, I do believe ready to put the lower half of this case on. I went ahead and put in a new crank seal to that lower case half off camera. So we got a new crank seal in. The only seal I can really think of at the moment that I'm not going to end up replacing is this governor shaft seal. I do have it in my rebuild kit, but it does require a stupid Briggs and Stratton reamer. It's not leaking, so I'm not going to mess with it. Where are we at? Let's put some slickum on that surface. Okay. Now very ginger-like. We will slide this all together without cutting our new seal. Oh, governor came off. Oh, you know you want it. So I am going to need to get a screwdriver to start that seal. Use that small pocket screwdriver to start that lip over the end of the crank so it doesn't roll. I do believe that's what we're hung up on currently. Which, take your time with this. You don't want to cut your new seal and have to redo this. Tedious crap that oops. Tried to sandwich my shirt in there with it. All right, seal looks good. So now, before I tighten any of these bolts down, I'll probably put a few inches to snug them up, and we're going to turn it over. Make sure the thing spins and everything's happy there. But being that this is the only gasket I have for this pan, and I don't want to buy another, it's not something you want to rush either. I mean, don't tighten everything down before you know it's all hunky-dory. I think we'll be all right. Those halves went together pretty smooth, but you never really know. Okay, let me get a pipe wrench and I'll get back with you. Well, in typical fashion, I went ahead, spun this around with a pipe wrench, quite a few turns, or full revolutions. Spins great, nice and smooth. I put all my bolts into the lower crankcase, went to torque them down to the book spec 200 inch-pounds. Very first one, pulled threads on. I then decided to back my torque down to 150 inch-pounds. Went around, made it down here, pulled the threads on that one. So I now have two holes with pulled threads. Every other bolt is torqued to 150 inch-pounds. In the future, if I go to actually install this motor in a mower or something, I'm probably going to have to take that off, get another one of these gaskets, and either time serve or Healy coil those holes
because I don't know how well this will hold oil. It might seal just fine, it might not, I don't know, but at this point that gasket's already torqued down. It's not like I can pop it back off. I mean, the gasket will leak if I do that, very likely, so we're going to run it like that, hope that it holds oil. What else can a guy do? I mean, this is just free engine that's going to sit on a shelf for who knows how long anyway, so I'm not going to stress it. I don't have any 5/16, what are those, 5/16 by whatever, 5/16 18, I don't know, whatever the standard thread pitch for a 5/16 bolt is. I don't have any Healy coils at the house that size, so we are going to move on to installing the cylinder head, I think, at this point. Bottom end's all buttoned up and good as it's going to get, so onwards. Alright, going to go ahead and put our cylinder head on. Book says 190 inch-pound for these bolts. We're going to run with that and hope it's right. And hope I don't pull threads from this too. The company I ordered my rebuild kit from decided it was a wise idea to take the head gasket and on one side of it put a used thin chintzy like oil filter box to protect it, and packing tape the gasket to the plastic bag with all the other gaskets in it, and then packing tape that box over that. Well, that likely destroyed this gasket. There was a big chunk that peeled off on the backside. I ended up spraying the copper head gasket sealer spray stuff on it in hopes that might save it. I guess we'll find out what I'm working with. Sometimes, you know, your parts supplier is an idiot and screws you over too, so where the hell's the dowel at? I think this thing's bent up too far. All right. Sitting on the dowels. Run a bolt in there to hold it down. Naturally, these have a 10mm head on them, it appears. And I still have a 9/16 socket on my drill, so, you know, an hour later I might have this one snugged up. Don't want to let go though, because the cylinder head will just fall off the dowels. Alright. Get the correct size socket. Oh, okay, never mind. I was gonna say, what the? Never mind, we're okay. Don't panic. I'm grabbing the 11. That's close to 10. Alright, take two. So, we got our torque wrench set to 190. Double check. Cylinder days, inch pounds 300,000 and 32,100,000. 190. So that's what we're running. Wish me luck. See, that just feels like significantly too high. I'm gonna back it off. I see a lot of other ones in here that are down at 165, so we're gonna go with that today. Wish me luck. That's it. 165 is what we're running. I am not going to pull the threads out of that block. That we're not going to be able to just say, oh, yeah, we'll run 165. Crucial thing is that it's actually torqued and the stretch of each bolt is consistent amongst all of them. So as long as they're matching torque, doesn't matter. It'll be fine. My kit did come with new valve seals. I didn't put those in either. Put them on the shelf, and if I need them at a later date, I'll use them. I don't need them. They weren't leaking. This thing wasn't burning oil, so. I feel like those are going to fall off and I'm going to lose them, so maybe not. Still got them gooped up. Should be alright. Now I'm going so good I can't get back on. So, let's move on. Now, if I were a betting man, I would say the aluminum push rod is for the intake and the steel is for our exhaust side. That is our exhaust valve. Need a light. Make sure I actually get it to the tap. Now, I'm going to go ahead and put the rockers on. We're going to get ready to set the lash. I want to review just to confirm that this is in fact for the exhaust side and that I have this all situated correctly. I want to review some footage, so I'll get back. I have a bit of a dilemma here. I guess first off, I went ahead and since I don't have a 31,000 or 310,000 series, God, that's going to kill me, 310,000 series manual, I went ahead and Googled some torque specs and I came up with 25 Newton meters for the cylinder head bolts. So I went around and tightened those up even more, 25 Newton meters. That comes out to like 220-ish inch-pounds. So did that. They all torqued down, didn't pull any threads, so plus there. Valves. This is where I'm having a dilemma. Now, I pulled up a Briggs and Stratton chart off the internet that states, what do we got? 7 and 12 thou for our clearances, whereas two other sites that I found stated a 31,000 series engine, intake should be 4 and exhaust should be 6 thou. Well, 6 compared to 12 thou is significant. That's more than enough to burn valves. And what did I have? 6 or 4 and 7, that's significant too. So I'm probably gonna look around a few more sites. I have it set currently to 4 and 6 thou, but I'm gonna look around a bit more before I say, yeah, we're gonna run that, because if I fire it up and burn the exhaust valve in the first minute or so, then not a lot of good this has done me. So do more research and I'll let you know what I figure out. Well, it probably would have helped if I read a little deeper. That Briggs chart I pulled up was in communist units. So it turns out, yeah, if we're using millimeters, that 4 and 6 thou is the correct measurement. So we're going to run them at that. So I managed to reassemble the rest of it. I have fuel system rigged up. I put oil in it, and I believe I have everything wired up the way I need it. So I have ignition voltage to the red wire going up to the stator, and the gray wire that goes to the solenoid on the bottom of the carburetor. And then I ran the negative wire from the stator to an existing ground that was shared with the negative side of the solenoid for the fuel shutoff on the carburetor. I wired that up there. So in theory, if my wiring is correct, I'll put that wire into the jumper box. I'll put a ground just right there probably. We'll touch that one off to spin the starter. Once it starts, we'll release that and keep this one held, and it should run. So I'm gonna get some fuel and I'll be back. So it runs, it hunts, and I don't know, I'm relatively confident we definitely have an issue with this carburetor. That didn't make a whole lot of sense, relatively, definitely. I am sure we have an issue with this carburetor. It is just dumping fuel into the cylinder. It'll run and run and run, and eventually just lock up from so much fuel in the cylinder. So I will be rebuilding that. In the meantime, I was going to show you that it does run. Yeah, we'll hit it. After we rebuild that carburetor, if we still have an issue with the hunting, then it's obviously a governor adjustment issue, but I think it's carb related. So, without further ado, let it run out of fuel. Well, there you have it. It runs again. I've run it off camera now for probably a good 10-15 minutes. Before the rebuild, with that kind of time, that thing wouldn't be running after probably 30 seconds, let alone 10 minutes. But at that point, the crankcase would also be full of diesel or gasoline. And I'll show you. It's not full of gasoline. It is in fact still fresh engine oil at the correct level. Cool. Don't smell any gas in it. So judging by what was happening there, how my positive clamp came unplugged, I have this lead connected to the positive side of the stator, and then you've got your diode in line there. And then it is also spliced into the positive side of the fuel shutoff solenoid on the bottom of that Nicky carburetor. When this came unplugged, it should have shut that fuel shutoff solenoid and killed the engine right away. Being that it didn't, tells me that solenoid is not closing. or even if it is, it's not seated. So, that being said, it is absolutely possible that that solenoid is stuck open, and even with the engine off and power disconnected, we're somehow supplying fuel through that carburetor and just filling up the cylinder. I don't know. May have to think on this one for a bit, but I think at the bare minimum we need a new solenoid, because it clearly does nothing. Other side of that solenoid's grounded right to the block. This side I should be able to put power to it, and the chunk open up, take power away, and spring pressure will push it back closed, so, or vice versa, either way. It's not working how it's supposed to. But engine runs, internals are good. It's not filling the crankcase with gasoline anymore. Still got nice and fresh oil. We'll call that a win. Well, might be a longer video. I appreciate you guys watching. Be sure to like and subscribe. And I'm sure I'll catch you on the next one.